Hello, my name is Marc Satkowski, and I will present you our work, Above and Below, Investigating Ceiling and Floor for Augmented Reality Content Placement. This is a joint work with my colleagues Rufat Rzayev, Eva Goebel, and Raimund Dachselt from the Interactive Media Lab Dresden. Augmented reality allows us to place personal and private content in our environment, which can be personalized and adapted to our current needs and wishes. However, as we place content mostly on eye level, this can lead to perceptual issues, like occlusion of the real-world environment, or to visual overload as virtual content has to compete with the real world. Additionally, as more AR applications make use of the eye level, there will be no space for new information. Therefore, we investigated alternative placement areas for future AR applications, like the ceiling and floor as demonstrated in the sketch. If we look at past work focused on either area, we can see two categories, either UV-Com solutions or personal augmentations. For monitor systems, the presentation is directly embedded into the environment, while stationary projectors solutions only project the content on either area. For personal augmentation, mobile projectors, either worn or equipped to other objects like drones, are an option. Lastly, a few projects also made use of head-mounted displays, either for VR or AR. However, what all of those have in common is that they present such a system and use case, but don't discuss how an optimal placement is achieved. With that in mind, we motivate our research project based on 3 research questions. The overarching research question is, are ceiling and floor promising placement areas for future AR applications? And following this, we further detailed 2 other research questions for our 2 studies, which I will present in this talk. The first one is, how do users perceive AR content displays on both areas in indoor environments? And the second, what does an optimal placement strategy for content on both areas look like? To be able to investigate the ceiling and floor, we implemented a small study prototype. It allowed us to control different parameters, like pitch or distance of content elements, but also the study procedure via a web application run on tablets. And transitioning to our first study, we designed a set of 6 content elements with varying levels of visual complexity, from low with icons to high with a cooking recipe. With this prototype and our research questions in mind, we designed our first study, a semi-structured interview with the following interview blocks. First, we wanted to understand the relationship between the distance and visual complexity, in addition to perceivable differences of private or public content, also regarding properties like billboarding. Next, we were interested into the posture and general perception and usability of either area. Lastly, possible interactions, but also functionalities, ergonomics, or other issues were of interest to us. Based on those interview blocks, we created 3 scenes for the study that are in line with the same blocks. The first scene allowed the participants to alter the distance, but also the type of content element and its placement area. The second scene contains several content elements on the ceiling and the floor, whereof some were equipped with a billboarding effect. Here, the participants should walk through this scene. Lastly, the third scene provided a simple gaze or proximity-based interaction with content on either area. Through the study, with 8 participants, we collected over 400 comments which were sorted via an affinity diagramming approach to create different themes. The 2 main outcomes, which are relevant for this talk, are that the placement areas are beneficial and usable, while the participants recognize differences regarding the visual complexity. This means that they saw content with high visual complexity, like the recipe, as not feasible for the placement on either area. Following, we thought about the question, what makes the placement of content on ceiling and floor different to content on the eye level? Looking at the sketch, we can see that the distance, but also the size of content allows us to calculate the angular size and the viewing angle, or in other words, how big or how distorted content appears to humans respectively. But as soon as we move the content to the floor or ceiling, we change both values to not be optimal anymore. this can again be achieved by altering another parameter, the pitch. With those three placement parameters, we can also calculate the angular size and viewing angle. But now to the question, why should this calculation be different between the ceiling and the floor? This can be explained by the human physiology. Since a room with an average ceiling height of 2.6 meters, the eyes are far closer to the ceiling than the floor. Further, the movement ranges of the neck and the eyes also differ for upwards and downwards movement, whereof the latter is more optimal for humans. To now find optimal placement strategies for content on either area, we conducted our second and this time quantitative user study. Our two independent variables are the placement area and the visual complexity. For the first, we have the levels of ceiling and floor, while for the second, low and medium visual complexities. We chose to not investigate high visual complexity as it was deemed not useful through the first study. Our dependent variables are the angular size and viewing angle together with additional questionnaires. The three parameters that allows us to calculate both values, the distance, pitch and size, were used to structure the study. For all three parameters, we defined a range which we used to create 5 fixed instances each. For distance, we used the range of 1 to 6 meters, for pitch from 0 to 90 degrees, and for size from 0.2 to 1.1 meter. The ranges were informed by a small pilot test for the size or the Microsoft guidelines for Solence 2 for the distance. With those three parameters, we created 3 parts, where within each part one of the parameters was fixed, while the others could be manipulated by the participants. Per part, we had 40 trials, which are based on the 2 placement areas, the 2 visual complexity levels, the 5 fixed parameter instances, and 2 repetitions. In total, each of our 26 participants had to perform 120 trials. We provided the participants with a tablet which was taped to provide some haptic confirmation while using it. Again, only 2 parameters were adjustable, while the third one, here in this example the pitch of 22.5 degrees, was fixed. Here are 2 other examples for fixed size of 0.4 to 5 meters, and for a fixed distance of 4.75 meters. Now coming to the results of our study, we will first have a look at the angular size, which is this angle. For the following visualizations, red is used for the ceiling and blue for the floor trials, while a dashed line indicates low visual complexity content. In this visualization, we can directly see a significant difference between the low and medium visual complexity content elements. Next, we will look at the viewing angle, which is this angle. Here, we cannot see such a clear difference right away. However, what we can see is a preference for an undistorted presentation of content, which means a viewing angle of roughly 90 degrees. Looking only at the floor, this becomes even clearer. Additionally, here we can also see a small plateau at around 30 degrees, which refers to user preferences, like in this case, placing content on the floor flat. This is supported by comments, like, on the floor, if possible, keep symbols parallel with floor surfaces so that it acts more as an inscription than an obstacle. If we look at only the ceiling, another preference is visible via the 2 peaks around the 90-degree angle. Those relate to the wish of letting the content hang from the ceiling, as signs were usually best read when hanging at a 90-degree angle vertically from the ceiling. In addition to this quantitative analysis, we could also identify 2 main goals of participants, which are greater readability and more comfort. Those are highlighted by the comments of, I place the object in a way that I can easily read and understand them, and all images should be placed in the best possible way and most comfortable for the eyes. All in all, with the 2 studies, we could create a set of 6 design recommendations, which are the following. First, ceiling and floor should mainly be used for secondary information and no primary task, which is further highlighted by the differences of visual complexity fitting for either area. This means content on the ceiling should only have low visual complexity, while the floor can also make use of medium content elements. Next, content should be placed flat on the floor as people can perceive it otherwise as obstacles, but at the same time still aim for optimal angular size and viewing angle by manipulating the other placement parameters, which are not bound by other means. Following this, we can define an optimal angular size for the visual complexity, with 6.5 degrees for low and 10 degrees for medium. Lastly, the content should be undistorted as possible, while specific user preferences should be considered, like hanging content from the ceiling. To conclude, in our work we focused on a static usage of ceiling and floor. This means a static environment, but also static content and a stationary position of the participants. In the future, a focus on dynamic parameters can be promising, either with different textures or content for and on ceiling and floor, but also with dynamic changing content or even moving participants. With that said, we contribute an in-depth understanding of the ceiling and floor as alternative placement areas, while providing an initial set of recommendations. We hope to inspire future research ideas and projects that make use of both placement areas. And with that, I thank you for listening. If you are interested in more details, please refer to our paper or even to our supplemental material, which also includes our study material and collected study data. You can find those on our here linked project page.